Okay, good afternoon, everybody. We're aware that this is the last one of the day, and we are all that stands between you and a glass of wine, so we will try and keep it entertaining at the very least. My name is Paul Hans. I am CTO of Parallel 51. With me is Ian Sloyan, Product Manager at Tokenovate. We are here today to talk about CDM, contracts, and AI. Streamlining collateral tokenized asset workflows, which it's quite a mouthful, and to be honest, we kind of decided we wanted to do something together, and we weren't sure what to call it in the first instance, so we lumped for this, and that's where we decided to go with it. We're not going to talk about what CDM is. Everybody here knows about it. Like, my wife's here, and she knows about what CDM is already. So I'm not going to bother explaining what CDM is. What we're going to do instead is talk a bit more about why it's important and how we can use it to go from first principles all the way through to sort of deliverable values. And it was talked about in the keynote speaks this morning about return on investment and about actually realizing some of the potential of not just open source, but CDM in particular. So I'm going to start us off, and I'm going to talk about the idea of taking what we've got in a paper format and then digitizing it and putting it into the CDM format. And as you can see there, I've got the question mark of easy, and I can quite happily guarantee that it's not. We've had paper contracts of legal arrangements for 40 odd years. They are older than I am, which means that it's very difficult to really try and represent this in a digital format. It's very tricky to pull all of that information apart and put it together. And we are in a position now where everyone understands that an awful lot of value in getting from paper data into actual digital data. There's a faster capacity for evaluation. If you are first to react to the market movements, you are usually in a better position. Digitizing your documents helps in that. There's a reduced issue, and it's something that's been talked about a lot today in this hub, of sources of truth and lost data. If you've lost an amendment somewhere for a CSA, for all you know, it might not be in the correct information anymore, and you might be acting in the wrong way and not in the way that you should be. And effectively having this position moving into the digital world results in people working faster, more efficiently, and more harmoniously. But underpinning all of that, and the most important piece of that, is the need to fix the data first. So if we don't have the data correct, people might be working faster, but they're working faster with the wrong data. You can't evaluate if that data is incorrect, and if you can't get into the digital area quickly and accurately, you end up in a big problem. So that's fixed data first. That's kind of the idea behind it and what we're trying to talk about today. The two questions are how and why. Realistically, there's the what, which is CDM, but we've said we're not going to bother explaining what CDM is today. And I believe that going from paper to digital is the first step on this journey, and make no doubt about it, that journey is quite a long journey. There's a long way to go from going from a paper contract to actually being able to see that value, that return on investment with CDM representation. But as we've said already with the fixed data first, getting that data wrong at the beginning can really result in magnified problems further down the line. That's the why. The how, and it's a shameless plug on our behalf, is using a common domain model and using what we believe to be the best thing, which is ARC51, which is us, which uses AI to pull it out. So what we've got today is a bit of a demonstration of just what can be done in the realms of the possible using AI to sort of digitize your paper contracts. So the first step on utilizing CDM is to go from something like a legal document. This is an ISDA Master Agreement that I've got up here, but the GMRA, the GMSLA, credit support annexes, eligible collateral schedules particularly, they're all very tricky to pull apart in terms of what is the inherent data inside it. Representing that in machine readable, machine executable sort of format, in JSON format, is a complicated and difficult challenge to overcome. So we believe we've kind of cracked it. And what I'm hoping to do today, or what I'm going to do today, you can't leave, is I'm going to be chatting to you and showing you just how we can get a CSA with an eligible collateral schedule extracted quickly and then put into CDM format, at which point then I'm going to hand over to Ian to go, and what can we do with it. So I've got CSA Megabank. This is our dev environment. All of the stuff is sort of made up data and made up contracts here. I've uploaded a document and I'm going to the system to say, what is it? Our AI algorithm has a bit of a look through and reads it effectively, OCRs it and tries its best to read it and determines what it is. That's how quickly it's done the first pass through. It goes through 2 pass throughs. The first one, it has gone through and it's identified this as a 95 English law VM CSA, English law CSA, beg your pardon, between Megabank Japan and Honest Bank PLC, which is correctly found. It doesn't have an executed date because it's a dummy document. The bit that we need to do is say, where should we take the data from? And importantly, where's the eligible collateral? Where is our collateral table for us to pull out what we need to pull out? It's gone through and it's had a look at that. Now it's going through its second pass through and it's actively looking at the eligible collateral schedule table and the rest of the document to try and pull the pertinent information towards this CSA. You can see, and this is real time, I haven't sped this up. So in a matter of minutes, we've got a representation of our CSA on the left-hand side and the digital representation of it on the right-hand side. So what that information is that we've pulled out. We can see there that the minimum transfer amount is correctly pulled that out. I've got a couple of examples that I picked just to sort of showcase that it is doing the correct thing. And I think the last one I picked is the notification time, which is the 1 p.m. London time. But a bit that's new and exciting is this eligible credit support, so the ECS table. So the AI is actively reading ECS tables are as varied as the spice of life is. We've worked out a way to actually get it to try and pull that information out correctly and represent it in what we believe to be a way that captures 99% of the cases that you would have. So we've represented that with all of the different bits and pieces, got maturities, got the treasuries, got the gilts, got everything else that it needs. And then what we can do is we can simply go into it and inside the mapping, we can represent it in CDM format. CDM is massive. It's a very, very complicated JSON structure. The legal agreement space, we've picked eligible collateral schedules and we've picked the credit support annexes because the elections that are currently in CDM are very well typed, which means that it's very easy to then make that machine readable and machine executable. And that's the direction that we are hoping to continue pushing. We are actively contributing to CDM to say that we need to do this more. I think I've got a pull request up for a GMSLA and an ISDA Master Agreement at the moment. I haven't done a GMRA yet, and I was hoping to chat to Tom Healy, but he keeps on avoiding me. So we've got all of the different representations kicking here, and you can sort of see it's pulling out the valuation, the haircut percentages and all of that. I won't let it go all the way through because it's quite long and quite boring, but I'm hoping you can see that that's a representation of CDM very quickly from paper to JSON format. And then the question then becomes, that's great, we've got it in digital format, but then what? What's the next step? What's the important thing to do once we've got this representation? And once we've fixed the data first, once we've got it into this CDM format, everything downstreams with digital contracts becomes a lot more robust. It becomes a lot quicker, a lot faster to react to the market. And if you are using something like CDM, and that's exactly what we would advocate for as the communication layer, it opens up a lot of non-competitive collaborative spaces for the respective experts to work to deliver the most value. I don't know anything about tokenization bar the very, very most basic principles of it. Our company isn't interested in tokenizing the assets and trying to do something post-trade. Tokenovate are. Instead of trying to do a one thing solution to fit all of the problems, let's have different solutions that can do their bit very well, and CDM is that communication layer between. And it opens up for a lot of collaboration. That can feed directly into, and we are working closely with, and this is a perfect example of that, the idea of moving that operations workflow forwards by bringing the different experts and the different vendors together to offer a full end-to-end solution. And that is the end of the digitization piece. And I will pass you over to Ian.
Thank you very much, Paul. You're very polite because we started late and you've rattled through it. Now, you are standing between people and drinks. I'm definitely standing between people and drinks. I'm Ian Sloyan. I work for Tokenovate. We are working to build CDM-based workflows and automate them. Prior to working for Tokenized, who I only joined this year, I worked for FINOS, and before that for ISDA. I've been working on the CDM since inception. I'm the guy to blame for a lot of this. So yeah, I'm very happy to see the likes of Paul implementing it and what we're doing at Tokenized. So let's get on and talk about what I'm going to talk about today. So I am here deputizing sort of for my colleague Kieran McGonigal, who is the chair of the CDM Digital Assets Working Group. So I'm going to talk about tokenization in the way we think about it and set some sort of basic understanding for it. Because I think people talk about a lot of this stuff and we think we know what it is and what it isn't. So we're going to go through some definitions to start with. So what is tokenization? So tokenization is the technological and legal process of representing assets as digital tokens on a DLT-based system. Tokenization is relevant for both the legal characterization of the asset itself and the settlement mechanisms used for its transfer. What are the different structures we have at hand? So it's not a single uniform process, varies across technology and law, requiring careful assessment of both aspects together. So we have different DLT architectures and technological implementations can lead to different legal outcomes, even when they appear to be similar. For those of you who don't know, Kieran is a lawyer, so we're taking a very legalistic approach to begin with, but we'll get into more of what we can do with CDM later. Legal recognition and enforceability in turn may depend on the token structure, particularly how rights are attached and enforced. The impact, small differences in functionality can result in significant legal distinctions in how a token is recognized and how and when settlement takes place. So this is really important with a lot of the regulatory decisions and the regulatory initiatives that are happening that Georgina went into in the last session, how things are treated under different laws, whether they're really tokens, whether they're securities, whether you can really own them or not. All this stuff is really important and needs to be addressed. Okay. Structures. Now, again, these are very legalistic for good reason because of the source. So, a crypto asset, a token that exists entirely on-chain, independent of legal systems. So, crypto assets, Bitcoin or Ethereum or whatever your favorite meme coin is, they're very popular, even with the president here. So, security tokens, a token that exists entirely on-chain, but which satisfies the applicable legal or regulatory definition of a security or financial instrument under local law. And then tokenized security, a digital twin token that represents an underlying security or financial instruments issued on a different platform. So these are the definitions that come from the CFTC GMAC Digital Assets Classification Approach and Taxonomy, which is nearly as snappy a title as this session today. So this is what we're talking about, and really where we think the benefit is in the bottom row in tokenized securities. That's how we think we can really improve collateral workflows and automate things that really should have been automated many years ago. Okay, so modeling tokenized securities in CDM. So how are we approaching it? Well, we've got the tokenized securities, which is one kind of area, and then and then the asset level, we have crypto assets and security tokens. Now, modeling assets in CDM, I think we've seen a lot of demonstration on the screen. It's really just putting in some identifiers and making sure we have the data structures in place to represent it. But then the settlement level tokenization requires a bit more processing and standards for how we're going to process those. But that's what the CDM Tokenized Assets Working Group is looking at, both sort of elements or prongs of the problem. So let's look at that in a bit more detail. So at the asset level, the token is the asset. It defines legal ownership and embeds rights and obligations directly in digital form. To model at the asset level, the CDM may be expanded to capture the relevant blockchain networks and legal frameworks to govern the token. So effectively, data model, a bit like the legal information we find in the master agreement. As those things are defined as standards, we need to ensure that we have that information at hand in the CDM. So we'll have to build those data structures out to represent the asset and its different, information on the blockchain network it's related to, or the legal frameworks that underpin it. So just for background on the right-hand side, so in this model, the issuer directly records digital securities on a DLT. So I think we kind of understand that. Now at the settlement level, in contrast, settlement level tokenization treats the token as a means of transfer, not the assets itself. That's crucial. So in this model, an intermediary holds conventional securities and issues legally linked tokens, and that's the really beneficial space, we think, for collateral workflows. So the legal and economic nature of the off-chain asset remains unchanged. We don't have to change the existing infrastructure, but the token acts as a programmatic or programmable settlement rail. So I bet we can have smart contracts running to do this stuff. The CDM must support new forms of settlement logic, such as atomic delivery, so where we can do buys and sells at the same time, and then the smart contract execution of what's happening. But we don't need to alter the legal characterization of the off-chain asset. Crucial if we want to implement the new technologies and implement automation and all the good stuff without impacting the existing infrastructure where all the liquidity is, where all the real assets actually exist. Okay, so we're going to get into sort of forward-looking what CDM can do in this space and tokenization more generally. So I've broken this down into sort of challenge and how CDM can help over the next few slides. So the tokenization ecosystem suffers from inconsistent use of standards. We see a lot of press releases every day about new tokenization, new DLT bonds, things like that. There's not a great use of standards, and we would obviously position CDM to be the standard that can help. So how can it help? So things like the digital token identifier, we've started working on implementing that in CDM and the relevant metadata behind it. We can embed legal, technical, and economic characteristics of different tokens and define them and standardize them in CDM. We can align with other industry standards. So as people are working to standardize in this space, we shouldn't think that we can do everything in CDM. Integrating with other standards or showing an integration path with other standards is just as crucial to be that fulcrum on which where people meet. So then we can really position CDM as a standards distribution layer, which is a different sort of way to think of a data standard or a common domain model. So we don't need to do everything in the way that Paul and I have presented today. There's standards for good reason with all the information, and as long as we can link to them and have a key connectivity. So the other problem that exists in this space is synchronizing on-chain and off-chain records. So I think Tom did a great demonstration earlier of a smart contracts running. So being able to synchronize this is key. So digital twins, they need reliable synchronization between the traditional books and records and the token itself. So CDM could model the off-chain state and the legal and economic position of the tokens and the real assets. It allows reconciliation and synchronization and provides an audit trail for regulated parties. So having lineage in the CDM as a model is a key functionality. So CDM is really perfect for this problem. So CDM will then standardize the data for symmetry between off-chain and on-chain assets. And then finally, as we move into the collateral space as promised, so what can we do? I think the challenge with collateral is that post-2008 crisis, regulation made collateral really an organizing principle for market stability. But it did really introduce a lot of complexity, and that change and the need for a lot more collateral to be moved and collateralization of products that were never collateralized before, it has increased complexity. So recent issues, the COVID-19 or the Ukraine war, we saw stress on the market. Particularly around liquidity. So how can we fix that? How can we make that collateral process a lot easier? Well, we've talked about digitizing the documents. So we can digitize collateral agreements into structured data. You saw structured data on the screen. You saw those JSON models. You saw them earlier when Vernon was explaining what's been done with the eligible collateral schedule models. We also have models for all the legal data, as Paul showed. So digitizing all that stuff in structured data models, all the rules like eligibility, haircuts, substitution rights, all that good stuff can all be contained in a machine-readable and machine-executable form. And then we can generate standard settlement instructions which are linked to the contracts. Speaking to a lot of clients lately, the idea that people only find out that they need to get a trade booked because the far leg of a repo has to be settlement, and they get a message from the CSD for their pre-approval for the settlement, and that's the only time they know, oh, we better tell the trader to book the trade. I don't think that's feasible in a state of crisis, never mind day to day, So that's a key part. So we can enable real-time margining and settlement, freeing capital and improving resilience. Now, if we free up all the capital, we can do great things, and that's a real key bit about the collateral space. I think we've, with the move to T+1 settlement, things like that, it's a much bigger. It sounds like it's a boring and not a very exciting topic, but actually its impact on the global economy is huge. And if we can solve some of these problems, those things can really come to fruition. So, just some information on the tokenized asset working group. So we're trying to solve all these things. What are we working on? So representing tokens that define legal ownership and embed rights directly on chain. So that's at the asset level, getting all that good information around those tokenized assets in there. Settlement level, we can model tokens as settlement mechanisms for off-chain assets. So being able to define those linkages to the off-chain asset or to the real-world asset. We can map tokens to their legal frameworks, custody frameworks. We can get all that information from the custodians and the rule books into CDM. We can add those new data attributes, and we're already working on this with support for identifiers like the digital token identifier. Again, laboring that point, we don't need to define our own identification system for digital tokens. Let's go and find a standard that's out there and just integrate with it. Lifecycle modeling, we can expand the business events to support conditional, atomic, and intraday settlement. They're just business processes, they're just steps we can define with rules, with steps, as we have done with other parts of the life cycle. So there we go. If you want to get involved, because it wouldn't be a FINOS conference without calls to action. And I didn't put up a QR code because, well, I can never use those online things. But it's a lot easier than that. Just email help@finos.org and join us to join the CDM Tokenized Assets Working Group. or you can use the FINOS community calendar. All the slides are actually going to be, they should be in your apps or online on Shed, so you'll be able to get access to these, and those links will work. Okay, now I've talked about tokenization. I talked about the collateral workflow, and you heard from people earlier today. Vernon was presenting all the work done on CDM for collateral. So, and we had Paul earlier talking about AI taking those documents. So, this is an example workflow. We can do this today. We have all the tools. Like, we can do this, no problem. So we can take legacy documents and we can run them through ARC51 and get them into CDM form. And then we can just build a workflow to do this using all the CDM components. So anything with the little, what are they, hexagons, is already in CDM. And then through our tokenized settlement work, we can interact with existing or digital custodians or legacy custodians to build this today. So I think we should just get on and do it, right? I just don't see there's nothing stopping us. So this is what's the art of the possible sometimes. I think that sounds a bit too futuristic. This is the art of what we can do right now with things we have at hand. And that's what we're trying to automate at Tokenovate. And if you want to see Tokenovate's demo on intraday repo, which is all automated, we'll be at the solutions showcase at 6 p.m. And I got to check what time it is. How are we for time? Bang on past. So I think we'll leave it there. If anyone would like a drink, I'm happy to buy you in that solutions showcase because I have a load of tokens in my pocket. Drinks tokens, of course. But yeah, thank you very much for your attention. And if you have any questions, please do shout out. We're happy to catch up later on.
Well, I guess, does anyone have any questions they want to ask? If you aren't desperate for a glass of wine yet.
Once you extract the data from the document, the instruction contract document, how do you generate the CDM object from that?
So that is a mapper that we have built. So we extracted, we were doing the extraction process before we really got into CDM. So we already had a digital representation of the contract. Excuse me, but once we do the extraction, we do have a human in the loop step, which is to go, okay, let's absolutely validate that that data is correct. Once we've done that, we have a built-in mapper inside the application that then converts our digital representation into CDM format to move out. If I was going to go back and do it all again, I still think we'd go down that approach. We collect an awful lot of data regarding, for example, the GMRA, the GMSLA, that as of yet isn't represented in CDM. So I think that while it's a brilliant solution, it's really good for collaboration, it needs to have more put into it before someone could realistically do the extraction side of things, and the legal representation of the contracts today would be lacking somewhat in some of the contract spaces that you have.
Then what's the accuracy percentage of extraction?
Oh, good question. It varies on the complexity of the question. So something like what's the base currency of the contract, for example, it's very good at reading that and getting that out. It gets that right. I don't think I've seen it get that wrong. I think we've got to the tune of about 2,000 extractions, and it might be 1,999 correct. The ECS tables are more complicated. We have used few-shot learning and a few different little bits and pieces to get that more accurate. We still actively believe, and we've got the data to prove it, that it's better than humans trying to put that data extraction and put it into the system. So it's a step up. I think for the ECS tables, we sat at about 95% accuracy.
But you teach it the templates, right? So if you know for a specific bank, say templates for contracts that are repeatable, then you teach the system, and then the accuracy is probably much higher.
Yeah, exactly right. Yeah, so that's the few shot learning kind of concept. Yeah, so we'll say this is an ECS table. Typically, we wouldn't say this is an ECS table and it is one of bank tier, like, you know, tier one bank, because at that point that's then giving the information to, like, that's technically proprietary data. It gets a little bit interesting and difficult legally, but we can go, this is an ECS table, this is an example that you've already seen that looks very similar, try and do the extraction from that point. Yeah.
So it gets most of the key operational data points out. Maybe not the esoteric legal clauses that don't do very much. There's no lawyers here, are there? No. Okay. Scott, I saw your hand up.
Yeah, thanks. On the previous slide there, when you had the flow chart of all the things happening in CDM, does the CDM itself determine that margin amount, whether it be
So,
for a repo or a OTC?
so there's So that's example workflow. That's an example workflow that we're working on building, but the key bit is that all the functionality is there, and the margin call function, the definitions for how to calculate the delivery amount is all in CDM. It comes from the legal docs, but integration. Same point I'm going to labor. Integration with external sources. The valuations are going to come from an external third party. The margin amount might come from an external third party. There's all different points in this flow that can be modularized and plugged in and plugged out. And I think that's the key design principle around CDM. And it's also the key design principle around Tokenovate as we implement CDM. So it's definitely in mind. Any more questions? Well, thank you very much for staying till the end. And yeah. Oh, wait, is there another one? Oh, yeah, thank you very much.
Thank you.